So now that we know that zeros of a functions are polynomial functions are related to its factors, using the graph of a function, we can identify easily some of its factors. So consider the following problem. We have got a quadratic function, f of x, and we want to, and we're given its graph, and we want to find a formula for f of x. Okay, looking at its graph, first of all, the important things to look at, which are the x-intercepts, and those are the x-coordinates of those x-intercepts will give us the zeros of the function, and therefore factors of the function. So if we look at it, minus 1, 0, 1, 0, those are associated to factors. So this one is associated to a factor of x minus 1, this one to a factor of x minus 1, in other words, x plus 1. Okay, so let's write this down. Since x equals minus 1 and x equals 1 are zeros of f, then x plus 1 and x minus 1 are factors. So therefore, f of x, so a quick and false answer would be to write, oh, x minus 1, x plus 1 is the formula for this function because I've got all the factors. Hey, hang on. Okay. The thing is, if we expand this, right, we're going to get actually a difference of squares. We're going to get this. But many quadratic functions have those factors. In fact, any of function where these factors are multiplied by some constant a, okay, because in the formula f of x equals ax squared, you know, a could be actually anything. So here f of x is basically going to be of the form a times the two given factors x minus 1, x plus 1, like this. So how do I find what a is? Well, we're going to use, okay, so let's use another point to find a. And here we're given that 0, 2 is a point on the graph to find a. So we're going to replace x by 0 in there, and we know the output is 2, right? Because 0, 2 is a point on the graph. So that means that 2 is equal to f of 0, and f of 0 I can calculate it with the formula I came up with here. This is a times 0 minus 1 times 0 plus 1, and ultimately this is just minus a. So that tells us that 2 is minus a, and that's equivalent to a being equal to minus 2. So now we've got what a is, and so therefore we know exactly what f is. So f of x is going to be minus 2 x minus 1, x plus 1. So in some cases, it's possible to recover the formula from the graph. Not always, though. Maybe some warnings. For example, if you've got a graph that's like that, okay, and it has like one, it's a quadratic, clearly, it's not a linear function, or it could be a polynomial degree 4, 2, and we don't know. But let's say we're given that it's a quadratic. Well, we've got access to, and it has only one 0, so we know that x minus 1 is a factor, but there's another one that could be a factor, right? But here, since it just touches 1, it's going to be x minus 1 squared. So this function would be of the form f of x equals a x minus 1 squared. So not so bad here because we can still recover the formula. But if we have, well, maybe I'll just keep that for you here. But I need still another point to figure out my a. But think about a quadratic that's like that, okay? Then I can't find really, at least there are no zeros, so I cannot have access to factors based on the 0, basically because there are no factors for f, okay? So I wouldn't be able to use this technique if the graph never touches the x-axis.